Okay. I just spent the last hour, instead of streaming, fixing my Vim configs, which was a giant pain. But here we are. Oh no. What happened now? It was just working. No, what's going on? Okay. Couldn't compile is fine, but now it's losing its mind. Let's try that again. Please don't lose your mind. Oh, sure. Tree error. Error opening file. Some Vim file. I was pretty strongly not wanting to be spending the stream working on Vim stuff. Environment stuff. The literally least interesting part of development. Okay. Error. Lua rocks not installed. Okay. Is this the thing? Nope. Parser not available for Lua. Sure, let's reinstall a little parser. Parser not available for Lua is what that says, right? Oh, language Lua rocks. Okay, that's presumably not what we're trying to do. And then install Lua rocks. Easily install. Lua Vim function executable Lua rocks does nothing at all. Okay, but it not being able to install stuff with LuaRox is not my problem. What's my problem? So we're fine here. NeoTree error. Error opening. I don't want to do this. Okay, so I haven't even installed the rest stuff yet, though. Which I probably should have. Astro and then Rust. This. Rust Analyzer. LLDB. Okay. Those are installed. Still doing the thing I was doing before? Question mark. Let's close everything. Okay, now it's just grinding to a halt. NeoTree error we get again. It doesn't even seem like what the problem is, though, does it? Okay, here's what I'm gonna do, because this is making me crazy. We're just gonna do this in VS Code for now. and hopefully this won't be miserable. Okay. Although, it might be miserable. Okay, let's get status. Why is there a package lock in my file all of a sudden? Like, I didn't put that in there. Weird. Okay, there appear to be some errors. All right, well, let's get started. So basically, where we're at right now, I'm not going to go through the whole prelude. If you want to find out more about the project, you can look at previous VODs. I usually do a thing, but I'm way behind schedule, so I'm not going to. But we are in the middle of updating SymbolNode, which is the core tree-based structure that defines statements, basically. And so we're going to replace it with a new implementation that uses binary encodings, but in order to do that without changing a gajillion things at once, I'm doing a janky thing where I what do I do? These are all the same. SymbolNode. Where when I import it, I'm importing binary symbol tree as SymbolNode, and I'm binary importing SymbolNode as old SymbolNode. And then we're working through the errors, many of which. What do I do? I can Control F through here. Many of which exist because I haven't implemented certain functions yet. So we will go ahead and implement those. So, oh my god. VS Code. What is the shortcut for switching files? Control Tab. But I needed workspace, and then 1075, and the point is that this can't do into on its own. Any chance I'm gonna get debugger output in here? Do I have to rerun cargo test every time? Because that's gonna be miserable. What is this? I didn't change this. So what's this? So interpreted string and type map. Oh, I missed my ID. Peek at definition. Returns a result. String and type. Oh, I'm missing. Okay. Find object. Shortcut. Shift L. Not what I want. Control Shift O. There we go. Okay. So what were we looking at? We were looking at get upstream statement and transformation. Which is where? Get upstream statement and transformation is here. Two interpreted string and type map. String and type map. Okay. Waiting for lock on the directory. Fine, let's just look for more errors. Fix that one, fix that one. Oh, here we go. Result. Okay. Result string, vec string type. Okay. And what's wrong with this? This is binary symbol tree. Needs a .into at the end. This still doesn't work. Because SymbolNode from binary tree needs to exist. From binary tree for SymbolNode. And then from, wait, not here. I don't get autocomplete. Let's just clone it for now. All I'm trying to do is get test passing so that we can benchmark this thing, and none of these are on the hot path. 6:30. Okay. Is join containing? Something like this. Just say if self dot is join return false. Self dot we could do get children dot contains, sure. Okay. Symbol. Ugh. Okay, I'll keep cracking away at these. Workspace error. 288. Parser parsed from string. And what's the problem? fine. Next, transformation 3406. Okay, there's presumably going to be a whole lot of this stuff going on. Ugh. Alright, let's cart a test again. Transform at. Yeah, okay, these tests are going to be absolutely full of places where we're comparing the wrong thing. You know what we should do instead? So in parsing, parser. Nah, I don't want to do that. I was gonna say we should just have the parser return the correct thing, but I don't. The parser should return a SymbolNode, I think. I guess we could do parse from string into SymbolNode, into binary symbol tree. Okay, let's do that. Oh god, done. Parse from string. Binary symbol tree into binary symbol tree. Self.parse from string custom tokens s.into. Okay, and then we anticipate that this doesn't know what a binary symbol tree is, so we add that one in. Okay, and now we anticipate a couple places at the end here where we put an into. Should not actually have intos. These ones are fine. It was like right at the end. I feel like there was another one, but and then what we'll do is we'll say in all the tests we want to update parse from string to be parse from string into binary symbol tree. And let's go cargo test again. And then so these are why is this an old symbol node when these are new symbol nodes? All right, what do we actually, stop, don't. What do we actually want these to be? We want them to all be new symbol nodes, but that's not gonna work because this takes other stuff. So we can do a little bit. What is happening? Start at the top. This is sort of miserable. There's no, oh, there is no here. Is join containing. Why is, so from is a binary symbol tree. Did I mess this up? Probably. Yes. Every time I save, the whole thing recomputes. Okay, transformation 332030. Apparently not. Apparently all my lines have moved around. Cargo test. Wait, didn't I parse from string? I thought I updated all of these. Let's try it again. Parse from string. Parse from string into binary symbol tree. Recompile this again. Okay. Contain substatement. Yeah, we just want this to be a hang on. Why am I needing to change this anywhere? Contain substatement. I found for binaries. So two statement, substatement, maybe two statements. Where's maybe two statement coming from? Maybe two statement is here. Maybe two statement options. SymbolNode. We're in transformation. SymbolNode is a binary symbol tree. Okay. So what seems to be the problem? So two statement binary symbol tree contains substatement. Oh, we just don't have contain substatement yet. Okay, that's a real one that we definitely want to implement. In fact, it lets us re-implement this in terms of contains substatement. Yeah. Okay, and then function contains substatement. Substatement self bool. Okay, so this is one of the ones that's recursive in the original implementation in binary symbol tree. In SymbolNode, in binary symbol tree, it shouldn't need to be recursive. Why? Because yeah, and this is just literal, yeah. So the other implementation is just recursive. So instead, what we can say is if self dot nodes let's see here, we'll just say self dot contains all nodes from substatement and self dot that actually doesn't work that well. If not, self dot contains all nodes from substatement, then return false. So now we want to scan function contains all nodes from substatement substatement dot nodes iter all substatement node self.nodes.contains dot get, say substatement label substatement root dot get label equals some substatement root. This needs to return a bool. And this needs to be a at self. This needs to be substatement label. Not stub statement. And substatement. Okay, good. Okay, and so then what's going to be the most efficient way to scan through this? Probably something like for I in 0 let's see here. So we want to just do this in basically on time, where on is the length of the bit vectors. And it can actually be a little bit better than that too. Self dot length in bits, and we don't have to go all the way to the end. We can go to minus substatement dot length in bits. And then we can say let alparens match let mute alparens match equals let mute j equals 0 will do, and then we'll say if self dot get bit, how do we do this? Bits, no, l left parens dot get I equals it's a nice way to do this. So the point is that j is going to increment. We're going to do I plus j every time. I plus j on the left and j on the right. So what happens if we say let L parens match equals, and I give you a function of I j and I say self dot left parens get bit from left I plus j equals substatement dot get bit from left j. And then I do the same thing for right parens. Substatement dot left parens and substatement dot right parens. And then and why are these yelling at me? Expected 2 arguments. Oh, right. Self dot length in bits. And substatement. Alright, let's do some helper functions for these actually. Let's do get left paren bit get left paren bit get left get right paren bit get right paren bit. Okay, and then we'll implement these as private functions. Let's do it down here somewhere. I guess the other thing we're going to need to do, we'll do it in a moment, is get trees match and this is going to be substatement dot node trees dot keys dot all label, and what we care about is what we care about is self.node trees dot get label expect. We already confirmed all the labels match, exist. And we'll just call this let self. Encoding be that, and then substatement encoding will be the same thing, but substatement, and then self dot encoding get bit from left, self encoding, self dot get length in bits, I plus j equals substatement encoding dot get bit from left, substatement dot get length in bits j. Yeah. And then we'll say L parens match. Oh, actually, we don't want to. Let's see here. If L parens while L parens match and R parens, this has to be ij, and R parens match ij, and trees match ij, j equals j plus 1. If j equals substatement dot length, return true, and then return false. Yeah, so what we're saying is so we're going to scan through by I, and we're going to say if the left parentheses match and the right parentheses match and the trees match for this bit, then we're going to advance j and look ahead. And then if j gets to the point where it's the full length of the substatement, we're done. And otherwise, we're going to return false. That all seems good and correct to me. We need to implement those getters. Get left paren bit self I usize bool. Why are they yelling at me? For loops evaluate to unit type. Got my return false in the wrong place. If I is greater than self dot or equal to self dot get length in bits, return false. Self.get self.left parens dot get bit from left. Length. Let's turn this into length. Length be this. I don't have to do this, do I? Do I? Just get bit from left. Always returns a bool. So actually I can just do it like this. And then we'll do the same thing, but for right. Substatement dot length. This should be length in bits. Okay. It's gonna be worth having a test for this, almost for sure. Test binary symbol tree. I think I'm going to try to get everything to compile first before I write my tests, because my tests will all be of the form do it to both types and then return. So I have a pretty easy way to do that. Explicit transformation, bias transformation, or error. This could be dot into for now. This could be dot into for now. Same issue. Type hierarchy, types should be fine. Instantiate. What are we in right now? some tests. Yeah, I don't care. Am I gonna need an add in front of that, or a reference in front of that? Yeah, I think so. Same thing here. Same thing here. Same thing here. Fix that one. Okay, let's cargo test just to keep our compilation relatively up to date. Many errors. Okay, with child replaced is another one that we're gonna definitely need to implement. So let's go. What did I just do? Contains substatement. What? How does it do that? Okay, so let's say with child replaced, and presumably this returns a self, although it might be a reference, I forget. Probably, or a result rather, with child replaced. Nope. With child replaced. Okay. Oh my god. Result. SymbolNode error. So it's going to be the ith child. And then one of these. To mute self. And it takes a new child. Okay. Okay, so again, we want to do this in ON time. Or better. So we want something like, let's split index equals self dot get child index I self dot split and insert split index new child, something like that. Get child index, self I usize, result usize SymbolNode error. And so to get the child index, we basically just need to count parentheses, right? Sort of. I'm having a memory of doing something like this already. Something with level. Get depth. Okay, yeah, it's a little different. Did I do get matching? I did get matching paren already. And where did I use that? Index. Get children. Okay, and get children and get child, I used it. Get split. Get child index. So maybe let's take get child. It's more or less going to be the same thing, except at the end of this, we're going to return child index. So let's move this down to get child here. Let's take this entire thing. And then let's say self.getChild index n the child index equal this. We'll just say match okay index and index error e then none then return none. And here we just say child index. Are there any other returns in this? No. This needs to return. Oh, this needs to be okay. And this needs to return error. Expected. But got. Let's say unexpected, right? Parenthesis. And here we'll say child index out of range is fine. Okay. SymbolNode error needs. Why does it do that? Literally, it maps me back to when I start typing. It doesn't stay where it is. It just peaks, but I don't know how to keep it from peaking. I don't know how to keep it there without touching my mouse, which is sad. Say unexpected parenthesis. That's fine. Okay. So nodes from okay, get child index, split and insert. Split and insert. Split index, new size, new child, new insertion. Self. This will take a new self. Okay, and so how's this gonna work? So we need to merge this is the location of the new child. We also need to replace it. Child replaced. Okay, so I'm thinking it's more like to replace index is that so let's call it replace. Oh, my function keys in it. What's happening? Replace from index. Let replace to index be self dot get matching parenthesis. Replace from index. And then it's essentially self dot get range. Get subtree starting at no, we don't want that. We want get range. Replace from index, replace to, nope, 0, replace from index. Dot combine. Dot get range, replace, nope, that's not right either. We need to just combine it with the new child. Dot combine. The rest. So this is going to be let the rest equal self dot get range replace to index. Self dot length in bits. Something like that. And combine. We'll take self other, return a new self. And we'll do self.nodes.combine. Is that a thing? Extend. What's the most idiomatic way to do this? see. Okay. Let's see here. 4K in self dot nodes dot keys. Let's just say self dot. And let's say new nodes equals self dot combine nodes other. I think we're gonna want to let this return an error. Results symbol node error. Seems all right. And then let new L parens be self dot left parens dot concatenate other dot length in bits, other dot left parens. Do the same thing for right parens. And then let new trees be what? Self.node trees dot clone or dot iter, I guess. Dot map. Self label. Self encoding. And here we do let other we'd be a little careful here actually. We have to be a little careful. Let me new node treat new trees equals hash map new for label in new nodes dot keys self encoding let's say let let get encoding is a function from label or SymbolNode name, probably a reference actually to self.node trees. It'll be from trees, which will be a hash map from something to something that I don't need to specify, I don't think. Trees.get, let's see here, match trees.get label, some encoding, then encoding, none, then binary encoding 0. And now we can say, no, we don't really need this actually. We can just say for label, let left equal self dot node trees dot get label unwrap or binary encoding 0. Let right, it's gonna be the same thing, but with other, and then left dot let new encoding is going to be left dot concatenate right, but I need to know the length, which is going to be other dot length in bits. And now new trees dot insert label new encoding, and then we do self new nodes, new L parens, new R parens, and new trees. And what's the worry with this? Sure. And here it's, this probably needs to be cloned. New nodes. Okay. And then function combine nodes self other results hash map symbol node name to symbol node root symbol node error, and this is going to be let labels be self.keys.union other.keys. .collect. I don't know if that works. We'll find out. And this is for label in labels. Left equals self dot nodes dot get label unwrap or let's actually do it like this. Where this is self.nodes. Self.nodes other.nodes. I really want to modify them in place, though. You know what? I gotta wrap up, so we're gonna stop here. Okay. Run this. We are making progress towards what I hope will be an excellent optimization. And look at that, we only have 213 different errors to burn through. Yay! Do feel like it's having to think a lot harder as it compiles now, which presumably means that some of these errors are being resolved. Okay. Intermediate state implementing combine nodes. All right, we'll stop there. Thanks for watching. Like, follow, subscribe, do all that stuff if you like it. It helps me out. I know we're doing a lot of development stuff right now that's kind of more tedious, but eventually I want more of this channel to be about using